ZombieTech. Welcome to ZombieTech, a forum for engineers, scientists, and inventors to ponder on the technologies needed to survive the inevitable zombie apocalypse.
She's Addie.
He's Whisker.
And who do we have this week?
This week we have Alex, the Canadian engineer.
Why's he got to be Canadian?
Because he is Canadian.
You're such a racist.
No, he is Canadian.
Why you got to be mean to the kid?
I'm not mean to the kid. I like Canadians.
Oh, yeah.
Hi.
They're all right, I suppose.
There's nobody can say anything wrong about the Canadians.
We've had a lot of good Canadian guests on this show, actually.
It is true. It is true. And strangely, all like electronic engineering
We've
students.
had a Canadian doctor student, too.
Oh, I guess so. A lot of students.
Yeah.
Yeah, you guys are all like in your
Because they don't have real
student.
jobs up there. They
I don't know.
just study to do something, and they never do it.
I don't know. I think Red is well, Alex is pretty freaking brilliant. So Alex, who I know as Red, because
he's like really red colored.
Yes.
On his hair, anyway.
Yeah, but flipping brilliant kid.
Oh, yeah, sure.
Flipping brilliant. So you are an EE, correct?
Well, if you want to go formally with what the Engineering Association in the province would say, I'm technically an engineer in training, as they would call it.
An engineer in training.
Yes.
So at what point do you become a full-fledged engineer?
Well, I'd need to get my proper full license for that, and that would take after about 4 years of work experience.
Holy buckets. And do you have to take a test for that, or?
There's a little bit of a test as well, yeah.
Oh, wow.
But it's mostly to do with the work experience and the references from that.
I see. Okay, so explain to me, because the last Canadian engineering student we had was going into his internship portion of the year. So how do the Canadians like do the schooling for engineers? Is it, well, for you, I guess, how did they do it for you?
So internships are a common thing in some universities.
Okay.
But they're often not required. It's some university programs it's a required thing, but often it's not.
Okay.
At the University of Calgary, where I went, it's not a required thing, but it's fairly popular for people to go on internship between third and fourth year.
Okay.
Gives them a little extra money before they graduate and such, and a little extra experience coming out.
That's actually pretty nice. So then it's 3 years of schooling, lecture, 1 year of internship, and then the last year of schooling, lecture. Is that how
That's
it
what
runs?
it was for me, yeah. Though it
Oh.
varies a lot from university to university, from college to college.
So you decided to do the internship too then?
Yep, I took an internship at IBM for 18 months.
Oh, okay. Now, because you're so freaking brilliant, right? I know you're not just one of those book learners, like, well, you could be, I don't know, just like an Encyclopedia Brown type of person, but, did the IBM thing help more with your work now, or do you think your cumulative schooling has helped more with that? Or is that hard to dissect?
So my guess would be that for the actual theories and stuff that he's using at work, school is probably more helpful. But to convey that certain engineering-centric sense of quiet angst, I think the time at IBM was probably more helpful.
The way I would put it is that my experience at school has been most helpful as far as the technical side of things. Though the experience at IBM has been good for the, I don't know, sort of the team environment there was quite good and
Angst.
good
Yes.
to get used to.
Oh.
All engineers have it. It's and once you have it, you get along with all of them.
What is this quiet angst that you're talking about?
Engineers just sort of have this way of looking at the world like management is out to get them a little bit.
I don't know. There wasn't much of that angst at my team at IBM. It was the management on the team was very good at insulating the team from the rest of the hierarchy.
To keep them from getting as angsty. Yeah.
I see.
Previous generations, they had angst issues, but they've worked it out.
I see. Well, that's good, though. That's good that for your internship you had that cushion.
Yeah, it was quite good.
Yeah, it's really cool that you get to work with what'll end up being your peers at the end of the day. because there's really no one else out there who can do a better job at sort of showing you the ropes of what the day-to-day is going to be than people have been doing it for a long time. So that's pretty cool.
So, as I always ask folks, what made you decide to be a engineer? And, well, EE, I should say, to be precise.
Yeah. Well, let's see. Just for a lot of my life, I've had an interest in both electronics and computers and that. Part of it might have been because of my dad being into that a little bit, though not really in the same way or extent.
Okay.
He was doing some computer consulting as a career for a while. And yeah. I don't know. It's just.
So it just made sense.
Yeah, it's just always been something interesting to me. One note is the program I went into was technically the computer engineering program at the U of C.
Okay.
Which is halfway between the electrical and software engineering programs there.
Okay.
It's actually maybe a little closer leaning to the electrical side, but yeah. I decided to go with that because I ended up wanting to just have a little bit of both worlds, really.
And that's funny because my next question was going to be hardware or software, but it sounds kind of like both for you.
The way I often like to put it in job interviews or whatever is that the closer it is to the boundary between the two, the more it interests me.
Ooh. And then they're all like, oh, good interview candidate. Oh. That's great. That's awesome. So then at your current job, I know you can't necessarily say too much about it, but what is your role and how does that compare to like other folks who are at your I don't want to say level because you're at higher level than they are, but like same like other people compared to other people that you graduated with.
Okay. So let's see. So my job title is technically GNSS firmware developer. GNSS standing for Global Navigate. I can't remember what it stands for anymore. Actually,
sounds like a bunch of management nonsense to me.
But it's just the acronym that refers to the global navigation systems that GPS is one of, GLONASS is one of, etc. So basic. And in terms of what I get to work on, so working at a small company, working at a small GNSS company, and as far as what I get to work on, I probably can't say too much in terms of details, but
sure.
Compared to a lot of other people I graduated with, I'm thinking I'm probably getting to work on a lot more variety of things than a lot of them, largely because I'm working at a very small companies where I get to wear many hats.
Sure. So you get to work. Do you get to work both on hardware and software then?
Don't get to work on hardware directly, but hardware considerations play a big part in my job.
Okay.
Yeah. He's writing firmware for flying cars that are very heavily armed to stomp down the Canadian zombie apocalypse.
Oh,
well, the Canadian zombies.
Front line of defense up
Canadian
there.
zombies would be too nice, though.
I don't think Canadians would build flying cars with like chain guns, though.
No.
I think they just like run them down with snow plows.
That'd probably work too.
Got a lot of those on hand.
So, okay. So, and then a lot, I mean, I'm sure you keep in contact with some of the other graduates. Like, what are they usually doing by now? Are they still just paper pushers or gophers or?
Not so much for the most part. But they are generally working in fairly supervised roles where they don't have quite as much opportunity for initiative as I have.
Mm-hmm.
That's not because they're not smart, because there's a lot of smart peers for my graduating class. The fact that I'm working at a very small company has given me a lot of opportunity.
Mm-hmm. Mm-hmm.
Yeah, it's something that's come up on the show many times, is that there's been a lot of specialization that's gone on in the workforce, and people are only allowed to do one tiny little job.
Almost to the detriment of their
very much to the
learning.
detriment. I think engineering in general needs to be more broad, and people in those roles should be allowed to be creative because it is a creative art, whether or not management thinks so.
Yep.
Well, it's very difficult because, you know, when you're looking at a circuit that's in a I don't know, finished product, like I don't know, I feel like there's only so much you can completely know.
Yeah, that's true. I mean,
Unless
really,
you're Red, you know,
no,
or
no.
Alex.
The likes of one of your past guests, Dave Jones, would be much better at that than me.
The whole
Well, with all the teardowns he does and such.
yeah.
But yeah, I don't know. There is definitely a limit to how much you can know. I mean, even if you are able to fully reverse engineer something that's already built, you still don't know the ins and outs of why decisions were made the way they were.
So that begs the question. So what? Okay, Alex here is. If you ever read any of my Tumblr posts, he is like number one person I say thanks to, or like the number two, because he always has a flipping brilliant answer, and he should be a professor. You should be a professor and like teach the world, right? So when you look at a circuit, I know this is slightly different because programming, well, I can't ask any questions about programming because you're programming hardcore GPS things, but when you're looking at a circuit, what are the things that you consider? Like, what's the first thing you look at or you say to yourself when you're looking at a given circuit?
Oh boy, that is such a big ball of wax because there's so many kinds of circuits.
Okay. I don't know. Gosh. Let's say like a simple transistor circuit. I don't know.
Okay.
No such thing, but yeah.
So, with regards to a simple transistor circuit, what you mostly have to first consider is basically you have to do a loop analysis of the circuit, which involves basically, if you could imagine your circuit schematic, you can trace a loop through different paths that current might be flowing in. And you can determine, say, how much current is flowing in that based upon what the voltage levels are at different nodes. And basically, you have to take it step by step of what you do know and what you don't know. You could argue that it's kind of like a Sudoku puzzle. Because you start with some things you know and some things you don't, and you just work through finding out the things you don't know step by step.
Yeah. So if you got a brain like Alex and you just look at a schematic, it just automatically turns into this big grid of, or net.
It's like a Tron. It's like a Tron movie.
Numbers that are going up and down, and yeah.
Oh no, it's not as natural to me as that, unfortunately. I wish. Though that does remind me that one common way that you can analyze such systems is you can turn it into a series of equations that you can turn to a grid of numbers.
Yeah.
And that's turning it into a system of linear equations, which you can use some tried and true mathematical techniques to solve regardless of what the contents happens to be. Which is how the spice simulators do their job.
Lieutenant Spice.
And why they're always inaccurate.
By the way, folks, I know it's not Lieutenant Spice. I know it's LT Spice, but...
Lieutenant Spice!
Simulating here for you, sir.
Well, that's not why they're inaccurate, Whisker. Why they're inaccurate is because they're making too many assumptions.
I'm being facetious. The reason why they're inaccurate to reality is because they're too accurate, right?
Well, yeah. Well, too many assumptions, basically.
So for you, for like a simple circuit like that, you look at the overall flow, so to speak, and then depending on the need, you go into the minute, right?
Generally, yeah, sort of.
Very interesting. I've always wanted to know how engineers when you look at this when you look at a ridiculously complex schematic, you're kind of like, well, shit.
Yeah, it's like that even for engineers. It's just you have to take a step back for a moment and start just looking at it in terms of small blocks that connect to each other and saying, okay, I know what this block does. I recognize an inverting op-amp configuration, or I recognize a Class A amplifier circuit, or just break it into small component blocks.
And so I I mean, I haven't been to engineering school or anything, but is that what they pretty much focus on? They just show you the blocks and then down the road, they'll be like,
well,
okay, in your future studies or future work, you'll probably see these different blocks.
not so much now.
No.
They do tend to focus on more the theoretical analysis of whatever might not actually match a practical circuit necessarily. It often does, but let me put it this way: the first focuses on the fundamentals of how you analyze the circuit, even if you don't recognize the circuit before, and that is a critically important thing.
Sure.
Though they don't really ever talk about the shortcuts that you can mentally take once you recognize circuits. It's not really anything that ever gets taught in the program.
It's just something that you have to learn to do. Got it.
And that just comes through experience, but yeah. I should probably find a good link on nodal analysis and loop analysis and send it to you sometime, Addie, because that might help you with the transistor circuits.
Probably. I don't know how much of it I'd understand, but hey, you are totally welcome, Professor Alex. So, in terms of projects, what do you have going on?
So few things right now. Let's see.
Besides, of course, Minecraft. Okay, go ahead.
So one of them that I have going on is a little board for driving a high-power LEDs, like you'd use to light a room, for instance.
Okay.
And automatically controlling the brightness. So I have a ambient light sensor on there, microcontroller, potentiometer, and that works okay so far, though I need to fix up the firmware on that a bit in order to actually control the lighting.
So the board tries to keep the ambient light at a certain brightness?
Yes, and you control that set brightness using the potentiometer on it.
Ooh, handy. That's very nice.
So the idea is that I have it set up like a lamp in my room, and well, I have the window open. If the sun rises up, it dims appropriately. If the sun goes down, it brightens appropriately.
Ooh. Are you going to put on Tindy?
Maybe eventually some future version, but it's not in the foreseeable future.
Okay. And then are you programming in C or?
Yeah, that is in C. That's a little AVR on there.
Okay, gotcha.
Propeller would be overkill, as would ARM.
Probably. But we love our propellers, so.
Mm-hmm.
Okay, so you got this cool LED thing, which would be very handy. You see, a whole bunch of zombies. I don't know, do you think zombies would be deterred by light? Probably not. They might get attracted by
Probably
light.
Not.
So, well, it could be a zombie detector, right? So when zombies come near, then the lights dim. Kind of.
Why would the light dim if zombies are near?
Oh, shoot. Well,
unless they're standing right over it.
Because it's scarier.
No. So then they wouldn't see you. Like, in the bunker, right? We're safe in the bunker, right? And
you think you're safe.
No, we are always safe in the bunker.
You've crammed like 60 people in this bunker. That's a whole lot of food.
Shoot.
The more episodes we add to this show, the bigger the bunker needs to get. Because
I suppose.
I don't know.
I don't know. I guess a light. Okay, fine.
Now for power saving, I think it's a great idea.
Yes. Hey, that's a good. Yeah, there you go.
Yeah.
That's because I'm clever. See.
Power saving techniques.
Yeah.
Now I have a question for you. The last time we brought a Canadian engineering student on, well, you're not a student, but he was. He suggested capacitive floors. Right? What's the word? Like
piezoelectric floors?
Yes. Correct. Do you think that is possible? Do you think that is feasible?
For sensing zombie locations, sure. For power, I don't think it's that practical.
Dang it.
Not unless you want to maybe, I don't know, drive a single night light from a big 100-square-foot area.
So, for all of you listeners out there in ZombieTech land, while Addie was waiting for the answer to that question, she literally crossed the fingers on both of her hands, closed her eyes, looked up, and was bouncing up and down in her chair hoping for a yes.
Dude, how cool would that be? That's all I gotta
Yeah.
say. That's
Zombie
awesome.
power plant.
All right, so it can light a freaking night light. Sorry.
If you have a big, huge area of it.
All right, back to the drawing board.
Might be more useful for sensor applications.
Sure, sure,
Just to power a remote sensor.
sure. Maybe you. Well, would zombies be conductive?
Not significantly.
Right?
We
I
wrote a
mean, not-
song about this, actually.
Did we?
Yep.
Well, because I mean, like, if they were, so then if they're not conductive per se, how would the capacitive plates? Oh, just the
The
pressure.
piezoelectric plates.
Yeah,
They just work from
just
mechanical
the
impact.
just the pressure. Correct. All right. The idea's stewing in my brain. I will figure it out. Okay, so continue. Well, so in terms of your other projects, so you got the super cool power saving LEDs thing that you're working on. Awesome.
Let's see. Another little project I'm working on that is also somewhat incomplete, but is turning out okay so far is. So had my digital SLR camera pointed at the sky with the stars,
Mm-hmm.
and while I was deciding what would let me get a more clear image of what's up there, because it's pretty dark and well, cameras don't work that well with that, and I don't have a telescope, so what I did was I set it up to take thousands of images over the course of a few hours at night, and have been setting up some software to deal with the fact that the Earth is rotating, so the star field is moving, so you have to, if you want to stack all those images up to get a more clear image, you have to make sure you align them perfectly with each other. And I've done a little bit of stuff with that so far, though it seemed like some possible distortion of the lens has been making it not work as well as ideal, but based upon short time frames where that isn't an issue, so far it's been able to let me see much better than the naked eye or the camera alone could see.
That's very cool. So
This
then,
lets me-
are you doing prolonged exposure?
Well, it's about 1 second exposures or so,
Okay.
and it's thousands of them. So I have to make sure to align them correctly.
So you're rotating
because
the
of-
picture to
Um,
match the other, or
rotating, shifting, etc.
oh,
So the software ends up detecting where individual stars are in each picture and using that to line them up.
wow.
Now this could work as zombie detection. Because you could take a picture in the dark
Right,
at the perimeter
right.
and tell if things had changed.
Yeah.
Yes.
The algorithms I'm using currently wouldn't be very applicable to zombies, but I mean, what I'm using to detect the star points moving is very specialized for things that are small little points of light. But yeah.
So how do you know? Oh no, go ahead. Yeah, go ahead.
I was just going to note, it's interesting with that because when I look at some of the stacked images, just zooming in on a point, even though I don't really have a telescope and I don't really have much zoom on my camera, I can still see some objects appear to most likely be galaxies rather than stars because of some of them I can notice an oblong shape to, even though they're only about 3 pixels wide. But yeah.
Wow.
Yeah, it must have been
That's
a little
cool.
confusing when dialing in your software. That oblong would be kind of hard to get around for detecting, because he's basing where to move the images in the stack, left, right, too, by detecting that points have moved. And if something is oblong, it fires off the point in a smeared way. So, are you accounting for that?
It's not that hard to deal with. I just the algorithm I'm using is one where I first detect the peaks of light that are the strongest in the image based upon basically a threshold and ignore points that are also peaks that are too close to them. And then what I do is I to get a finer idea of exactly where the point is, to a resolution that is even better than the pixel on the camera, I basically take a weighted average of where the center of the object is. So, say, basically, if you have an oblong object, it'll basically detect the center of mass of the light, and it'll track that location regardless of what the shape is.
Hmm.
So the short answer for everyone out there is yes. He's accounting for that.
Yeah, sorry about the long-winded.
No, it's really cool stuff.
That is very cool stuff.
Yeah, looking at it like that instead of as like raster information is kind of nice.
Mm-hmm. Yeah, it's a fairly standard way of dealing with tracking blob-like objects. Had a little exposure to that in university during one course that had to do with computer vision.
Interesting. Very interesting. Everybody, Alex, the genius. Very
No,
cool.
we're not a genius.
Totally a genius. All right, so you've got super cool LED thing. You got a star field tracking program. And what else you got? What else are you working on?
Let's see here. Another project I'm working on that I know Whisker knows a little bit about is one where I'm trying to set up a little bit of a system for bit of a homegrown audio interface system.
Okay.
So the first step that I've built so far is just an audio capture board that has a very low noise ADC on it, some input buffering for that, and an FPGA on it. Planning to expand it to have some other capabilities for playback of audio as well later, USB connectivity, and also been thinking about some applications involving processing on the board itself, such as, well, phased array microphones, which are an interesting thing because that would let me basically virtually mic any given location in 3D space with an array of microphones at fixed locations.
That's very cool.
But he's not a genius. We have to be very clear
Right.
on this.
Right. So, let me see. It was an audio. The first thing you said, it was an audio input. Audio input. What kind of
interface?
Interface. No.
So like a really expensive sound card that, in my world, bolts to a rack that you hook to a computer to record multiple channel audio. Typically, he's building his own from scratch. But he's putting some features on there that you can't get on
a normal
commercially available stuff.
Mm-hmm. Taking it step by step, slowly with just the audio capture for now, adding later parts later. It'll take a while for me to get this project complete. But
I don't want to rush him, but once you get that working, and we're gonna help you beta test that, and it's going in the rack here in the studio, and hopefully someday ZombieTech will be recorded through an Alex brand audio interface.
That'd be so cool.
Yeah, maybe someday.
No pressure. So why audio?
Well, it's a little bit of an interesting thing to me. Actually, the idea of doing some phased array microphone stuff has been something I've been thinking about since high school, even. Just more of sake of interest, more of the techniques used and such. But also, I'm interested in audio because I'm a little bit of a musician. I haven't played much lately, but I have learned the violin and was playing since the age of 3.
Mm-hmm. Woo!
So yeah,
Very
it's a fun
cool.
instrument.
Very cool. So then, okay, and from context, I can guess what phased array microphones are.
I'm sure most people out there probably wouldn't know those, so you might want to explain that.
Yes.
So the idea is that if you take, it applies not just to microphones but to antennas as well and other things. So what you can do is you can take multiple receiving elements and that are receiving the sound waves and put them at different locations in a bit of a grid, or even just a line for a simple one.
Mm-hmm.
And what you can do is you can look at the phase of the incoming wave, basically the timing of as the wave comes in, and you can detect things such as the distance. You can detect the location of the source of a sound or radio signal or whatever by comparing the phase, because
Oh.
the wave propagates from its source at a finite speed, so it will reach the different receiving elements at different times. So you can use that data to find the location of things, or you could try to filter out sound, so you're only getting something
Electrically
from a
from
source.
the element to whatever's looking at them, your lag is fairly minimal. So
Yeah.
you're getting the wave at different points in its own propagation length from its source on each one of the elements. And because of that, you can see that it's in a different part of its up-down cycle, if you will. Just think of a sine as an easy example. It's going up, down, up, down, up, down. And all of them are going to be slightly different up and down, different amplitudes.
Yeah.
Okay.
And by looking at them for a short period of time, you can tell which one is out of phase in which direction relative to everyone else.
Mm-hmm.
So then is your system eventually going to like match those? Or
Sort of. Like, one thing I was thinking about was having it use that direction finding capability to keep track of where a sound source is and keep a virtual mic close to that location at all times, basically filtering the input data so that signals that are at that sound source are the strongest and other ones are cancelled out.
Now, keep in mind, if something, Eddie, is 180 degrees out of phase,
right, it cancels
with your primary virtual microphone that he's talking about. That when you sum the two together, it would actually lower the output. So by selectively picking the mix between all of these inputs, he can avoid the out of phase material and stick to the in phase material.
Yeah. Selectively picking the mix and shifting that in time slightly and that sort of thing.
Now, does that precise method of recording, like by actually looking at the waveforms and quote unquote tuning according to the waveforms, does that sound better or more clear than just doing it by ear?
Wouldn't really sound any better, no. It's more just that you could do something like you could effectively have a room where something that you want to record is moving around, and you can mic it without actually having to physically attach a mic to it and still do it effectively.
A virtual mic
like
could
that.
follow it through the room as it's moving.
Yeah.
Interesting.
And you could also apply that type of thing to things besides recording, like, say, if you wanted to, say, track where a plane is in the sky, you could use a phased array to know where that is.
Terrible example. We're tracking
It
zombies
is.
on the perimeter.
True, you could use it for that as well.
Oh, he's right over there.
Yeah. Yeah. It's interesting, like, phased arrays with radio antennas are often used for things such as military radar systems and things like that.
Sure.
How about those big linear arrays of radio telescopes?
Yeah, I imagine those probably basically use the same principle, yes.
It's all about the waves, man.
Yep.
Waves.
That's something that would be very interesting to study up on, I think.
Yeah, the part about the radio telescopes actually specifically reminds me of another application for the acoustic phased arrays thing, is you can basically take a picture of a room based upon sound. Like, say there's a sound source, you wouldn't just see the waves coming from that sound source, you would also see the reflections off everything, etc., and you could detect the direction of those reflections as well.
There's a game that does that.
Oh?
Have you? I don't know if you've seen it, and I wish I knew the name of it, but I'll find it.
Devil's Tuning Fork.
Yes, Devil's Tuning Fork. It's
interesting.
Based on you have a tuning fork and you're hitting it constantly.
Slap it against something.
Right.
And then you see the echoes that come back at you. It's a creepy game.
It is a really creepy game.
You're blind, and the only way you can see is by thwacking your tuning fork.
Right. And then it shows like this whole this whole room in front of you.
Including like monsters running at you, and you just get sort of flashes of them getting closer and closer.
Weeping angel
yeah.
style.
Zombies. Arr.
Yep.
Yeah.
Yep.
Interesting.
Oh, actually, that's kind of neat.
Yeah.
It's a pretty smart
It's
game.
really cool that you can get a 3D picture of a room from just letting some wide frequency band stuff loose and knowing what frequency you're letting out at the time. You could do a frequency sweep almost and just get every single aspect of a room if your array was good enough.
Yeah,
Now-
or you don't even need to you don't even need to emit sound. You could just passively do it with sound sources that already exist in the room.
It might be more difficult though because
It
you
would
don't
be. It
know
would.
what the base frequency is at any moment, so you'd have to be figuring that out all the time.
So let me
Yeah.
ask, okay, if you can input, or if you can do this audio capture where you get the relative location of your sound, when you put it out through the speakers, can you paint that same picture into the room using say your surround
So
speaker
you're talking
system or
about
whatever?
a speaker array instead of a microphone array.
Right.
There's all sorts of interesting things
Yeah.
you can do with multiple speakers in a room.
You definitely can. You definitely can, though there's some limits to it because you're going to be putting your sound into an acoustic environment that has its own reflections and such, and
Yep.
Mhm.
those could cancel with the output of your array in various ways, and it could get messy.
I see.
Bob Carver came up with a really cool system that used 2 speakers because that's controlled enough that he was able to pull it off to give completely discrete perceived signals in your left ear and your right ear.
Yeah.
So he was able to send extra material out of each of the speakers that would propagate to the other ear and would propagate there at the exact point and be out of phase to cancel out the things he wanted to cancel out. And with the
Yeah.
opposite speaker, the same story. So the material would get to the ear that you wanted it to get to.
It's kind of
cancel
creepy.
out what you didn't want to get
Yeah.
in
I
the other
imagine
ear.
that requires some pretty precise positioning of the head versus the speakers, though.
Yeah, you had to sit in the sweet spot for it to work,
Yeah.
obviously.
Very interesting. Very
Pretty cool.
interesting.
Reminds me of one thing I heard about where some experiments with directed audio that involved modulating a normal audio signal on an ultrasound frequency signal.
Yeah, let's not talk about those because I don't want them to actually start using them. I think that's really bad
yeah.
technology, and I think we should basically burn down the factory if they ever start making them.
Wait. Is this like subliminal messages?
No, it's not subliminal. It's basically a cone of audio, or even more fine than that. So you can have audio that's audible at a particular location and nowhere else. And one of the first people that they're trying to sell the idea to is grocery stores.
Yep.
So that
Oh, right.
when you're in line,
Right.
it'll blast advertisements
At
into
you.
your ears
Based on you.
without
Yep.
anyone else hearing it because you're right there.
That's
So anywhere where
right.
they're funneling people into corrals like sheep, they're going to be aiming these things at your head
Wait.
and
Now-
advertising to you. So no, Whisker says
And
no.
most annoying tech ever.
Enough's
Well,
enough.
maybe not most annoying, but very annoying. tech.
Probably very close. So wait, I think didn't some guy go on to TED and show
Yeah,
his speaker doing that?
yeah, he's been on there.
Oh, is this Bob? No.
No,
Oh, okay.
Bob Carver is he's famous for making speakers and amplifiers.
Oh, I see.
It's an audio
Audio
like
guy.
a home audio kind of guy.
Very interesting. Very interesting. I think it's sad that tech, though, these days is trying to figure out how to get more advertisements.
Yeah, one of those
into
founders
more
of
use.
Facebook guys is quoted as saying, I've seen the best minds of my generation wasted on trying to get as many eyeballs looking at advertisements as possible.
Yep.
And that's absolutely unacceptable, and we need to fix this.
Yep.
So then let me ask, so this is an audio project, and I notice a lot of engineers end up doing audio projects like synths and stuff like that. Is audio and RF kind of like the challenge for a lot of engineers? Like, well, I want to work with magic, so let's work with audio and RF.
With RF, I think it's probably a bit of that. With audio, maybe to some extent, but I think it's a little bit of a simpler thing in many ways.
Okay.
But
I'd like to say that I think audio is magic, and I like working with it. But that RF stuff is over my head, so I can't even
I'll
approach
say
that.
Audio's magic and RF is black magic.
I see. Okay. That works. All right, and we're going to shift gears slightly, even though like that project actually sounds a lot cooler than what I thought.
Yeah, we're going to be
It was
talking
gonna
about
be.
that project a little bit more on Patch Bay
Yeah.
.tv this week. So
Yes.
yeah, if you're interested in hearing more about that, just head over there and give the show a listen.
Yes. Robo code, which sounds freaking awesome. I was stalking you on the net, Alex, and
She does this.
It's true. And I found this old user page, which actually isn't that old, maybe from last year, 2 years ago. And it was on RoboCode and some of the projects that you've done in RoboCode. What is RoboCode?
So it's a little bit of a programming game where you program some virtual tanks to aim at each other or dodge the shots from each other, and it's a really interesting game from the point of view of there's a lot of machine learning algorithms involved these days.
Mm-hmm.
In the early days of it was pretty simple stuff, but these days it's all sorts of algorithms involving what's his name? KD trees and other algorithms for allowing a robot to detect similar situations that's encountered before and predict based upon that, and pitting learning algorithms against each other, and it's all sorts of fun.
Now, I know Whisker's done some computer learning stuff via neural networks.
Sure.
Is that at all similar to the RoboCode learning?
The applications is a fair bit different, but there are some neural net-based ones out there. They're not the most successful usually, but they do all right.
Mm-hmm, mm-hmm.
The most successful algorithms are usually ones based upon sort of statistical counting of what happens and some assumptions based upon the rules of the game and that.
Okay. So let's see. You have some released bots, which have some pretty cool. I don't know. They have some cool names. The Lunar Twins. What do the Lunar Twins do?
That was the first one that I publicly released, which was an interesting one because, well, on the RoboCode wiki there was a bit of a competition going on for a format of battle that is two robots versus two teams of two versus each other.
Okay.
And so when you have teams in that game, the two robots can communicate with each other and pass information along, and you can have the two cooperate with each other.
Mm-hmm.
And most of the ones in that competition at that point were fairly similar to the types of robot designs, the types of AI designs that were used in large battles between many robots where you just had to dodge everything and keep a good distance away from everything.
Mm-hmm.
But with Lunar Twins, I decided to take a bit of an approach where I'd use the two allied robots to corner and pin the enemy ones one at a time, which turned out to be so successful that it beat every other one in the league.
Nice! Woo! Good job.
So over time, people have found some ways to counter that strategy, but yeah, was interesting.
That's awesome. So, like, I mean, and I'm kind of imagining. Have you ever played the Atari?
Tank.
Nope.
Tank.
Yeah,
I'm just
He's
thinking
like 12
of Tank.
years old. He doesn't know what Tank is.
Not quite 12.
12-year-old
No,
genius.
yes, I'm not. I'm
That's
too
great.
young for Atari.
Oh man. Okay, because there's this game that's called Tank, and you have one tank on either side of the screen.
Addie's also way too young to know what tank is.
But I've played it. I played it on the actual system because the person's house who I went to was much older, so they had the
Yeah.
system. And I think so. You have your enemy tank who's like trying to kill you, but obviously you're smarter because you're a person, and so you go and you try to kill it.
Yep.
So that's what I'm imagining in my head with these bots. How complex? Because obviously you can get it to the point where they can learn how to corner one, enemy. But how complex can these bots get?
Well, if you're talking in terms of lines of code, the complex ones get to many thousands of lines.
Wow. Okay.
It's largely because the learning algorithms that are getting involved in the high-ranking ones are just really freaking complicated. And the other part that gets complicated is when you have to program your one to dodge what the enemy fired at, you have to not only predict where the enemy fired, you have to consider, okay, I have this much momentum right now, and I can slow down by this amount, and these are the locations that I can get to, and
That's crazy. That sounds nuts.
Sounds like fun.
Sounds nuts. So is it like you program them and then you get them to go and then it's on their own from there?
Yep.
Oh, wow.
I think you need to come up with a variant version of this called Zombies versus Podcasters. And you get to choose whether or not you want to release zombies into the arena or if you want to release podcasters into the arena. And you write their little learning code.
Oh my gosh.
Hopefully the podcasters win because that's my team.
Yeah.
Yes.
All right. So tell me what Polished Ruby is for. The strongest mirror movement bot ever with a wink.
Oh.
And when you wink,
That one,
I'm scared.
It's a wink
That
heard
one
by
was-
1,000 people.
That one was just taking the targeting system of one of my more successful robots, Rouge DC, and combining that with a simple mirror movement.
Rouge,
Now what,
Ruby, Red. Anyone saying a theme here? It's got a thing for Red. I think we all
Now-
kind of have a thing for Red, though.
Yeah, so anyway, the mirror movements in Robocode are just simple movements that try to keep on the exact opposite side of the field from where the opponent is.
Okay.
So theoretically, the thing is that if the opponent knows you're doing a mirror movement, it makes your robot very weak to the other because they know exactly where you'll be, so they can fire exactly where you'll be.
Right.
On the other hand, if they're not aware of that, then it means that your robot's movement will be basically just as unpredictable as theirs unless they're aware of the fact that you're mirroring them.
Right.
So it can be an advantage if it's fighting a robot with a stronger movement than one that I've designed myself.
Right. Now, are there and real quick, are there more than one bot? Is there more than more than two bots in say a 1-to-1, or is it like, because I'm imagining like 10 bots that are all attacking each other at once, or is it like a 1v1 type of thing or 2v2?
Well, there's both. The standard league is a 1v1 league.
I see.
But there's also what's called a melee league, which is just a 10 bots free-for-all type of thing.
Okay. And then Polished Ruby you would use probably not in the 1v1 because they
That is the 1v1.
Oh.
And the only cases it really wins in are cases where its targeting system is stronger than the enemy one by about 5 percentage point. It's really not that... I really didn't make that one as a competitive one. I made that one more as a useful benchmark in the league, because if you lose to it, then it indicates your targeting system is worse than it by some amount, and you can estimate that. So it makes it kind of a good benchmark.
Sure.
Because it takes the movement out of the equation.
Sure. And so then I'm imagining people still do this. Are there like tournaments that go on for like ultimate glory or?
So the way it works is that there's kind of an ongoing tournament where it's kind of like chess leagues, really, because there's constantly all the different bots are battling each other on. It's a distributed system where people can run it on their computer to contribute battles to the league, and it's constantly ranking them against each other.
Gotcha. That's really cool. Actually, this game looks. It reminds me of Core Wars, but like visible Core Wars. You know what I mean? And I like Core Wars, even though I've never done them. They just sound cool. Robo Wars. Excellent.
So ZombieTech, we've got algorithms at war and beekeeping lately. So that's pretty awesome.
Yep.
Or random in a good way.
Yes.
But one thing that's not random about this show are 3 questions.
No,
like
2.
2? Just
2.
2? Well, maybe I've got an extra question this week.
All right, fine. So, as you know, Red, or Alex, I used to call him Red. Okay, we got the 2 questions that we always ask every guest here on ZombieTech. First question: what 3 tools would you bring to the zombie apocalypse bunker? When you what 3 tools?
What 3 tools?
A passport, because the
no, they're not gonna
bunker's in a
care at
different-
that point.
I suppose not. Either that or
The
the
zombies will have gotten rid of the
more.
border patrol by then.
Maybe.
Maybe.
All
I don't
us
know.
northern zombies are going to be traveling north to get good beer.
There's good beer up north?
Yes.
Oh, I don't know.
What 3 tools? Let's see. I'll say duct tape is one of them.
Okay.
'Cause it's
That's
pretty
appropriate.
universally useful.
Yep.
So he goes by Red. Have you seen the Red Green Show?
Nope.
It's
It
a
is
Canadian
really
TV show.
funny. Like super
Okay.
funny. Just pun upon pun.
Yes, and he likes to use duct tape to do things like build cars and
Mhm.
yeah,
Mhm.
Okay.
Canadian engineering at its best.
Mhm.
Let's see.
I know you
Well,
listen to the show, man. So if you didn't come prepared, then I'm gonna have to judge you harshly here.
Yes. Didn't prepare as much as I should. Let's see. A large bag of transistors, because there's a hell of a lot you can do with them.
Okay.
From making an AM radio, AM transmitter, whatever.
That's a pretty good one, actually. Now
Okay.
the real question is, what kind of transistor? Or just like a big mix?
Probably a mix, but mostly NPNs.
Okay, because I would definitely go with the NPN route personally.
I mean, really, anything you can do with NPN, you can do with PNP. It's just a matter of getting your mind the opposite way around.
Right. Which is
Really-
difficult
Yeah.
for me anyway.
Mostly just you have to flip your voltages and currents around the opposite way, and
I
it'll
think the
work.
PNPs are backwards,
Yeah.
personally.
I was like, what? They're open if it's low voltage? This is confusing.
I like the ability to connect things to ground or disconnect them from ground, so NPNs are nice.
But whether negative is ground or positive is ground, that's really arbitrary. You could have a circuit running with ground and negative 5 volts if
This
you
is
want.
why we don't invite you to parties.
Let's see, and the third thing. For a third thing, I will have to say a hatchet.
Okay.
Good for getting through things and not too heavy.
Okay. A
So
hatchet.
duct tape, a bag of transistors, assorted, and a hatchet.
Assorted. Very
I hope
cool.
you're bringing friends who brought food and water, but yeah, that's
Oh yes, those are important.
Excellent.
you could probably get those 2 things with that combination of items, so that's good.
All right,
I
and
don't know how the
then
transistors apply to that, but hey,
all right, and then the book you would bring to the zombie apocalypse bunker.
this one should be good because he's like an info sponge kind of person.
Book.
I'm just bringing Red. That's my book.
I agree. He's a genius.
Let's see. Honestly, I feel like in the zombie apocalypse, it'd be good to have just I mean, if one already knows what you need to know, and if other people are bringing books like the Zombie Survival Guide, then might as well bring an entertaining book like, say, Dune.
Dune,
Okay.
huh?
You seem
Yep.
to be like a very Dune reading person. Like, if I had to pick a person to read Dune, I think that would be you. I don't know why. It just seems very. I think that's a good match right
I think
there.
my mom would also choose Dune.
Yeah.
Yeah,
I kind of got it, but I didn't quite get it all the way.
I didn't quite get it either.
Yeah. I was reading Ender's Game at the time,
Giant
so.
worms were pretty cool, though.
Yeah.
It's
Didn't they poop minerals or something?
pretty much,
Yeah.
sort of.
All right. Yeah, see, I don't even know if I remember that like correctly or not, but all right, Dune it is. Sounds good. Duct tape, transistors assorted, hatchet, and
A copy
Dune.
of Dune.
a copy of Dune.
Yeah,
Right. Is there a series with that?
yeah.
Okay. I
Mhm.
clearly did not read it. I think I about read Dune, and that was about it. All right. Did you have one more question to ask? Because I think you said 3.
Did I? Well, no.
No. Okay. So, you don't have a blog yet, although you're
Not yet.
right. Although your brilliance can be found
When he
in-
gets around to documenting these projects,
Yeah.
we'll probably get him back on or something.
Yes. Sounds good. And if you guys want to see how smart he is, just like Google Red or like Rednaxela.
I don't think Red's gonna get you
Well,
very far.
Rednaxela is not a complete unique nickname, though.
That is
so
true.
note that not all occurrences of that will be me.
That is true.
After all, it is just Alexander backwards.
Right. And yes, and he is on Twitter, Rednaxander. So, follow him. 1, 2. I always refer to him. 3. B, C. Freaking brilliant. Really, really just. He knows how to explain it to newbies like me, and I appreciate it.
Yeah.
So.
So if you want to see all of Addie's blog posts, where Red and
Has essentially
and
written
Mike
it.
Burr and John S.A.Z. and Roy Eltham and all of the regular cats in the Toymakers IRC channel have been very, very helpful
Yes.
in helping her figure out how to do a lot of the stuff that
Yes.
electronics noobs find puzzling.
Mm-hmm.
You can find her stuff over at, what is it?
tymkrs.tumblr.com.
Yeah, Tumblr without the E
Mm-hmm.
before the last R.
Mm-hmm.
Because, spelling is hard.
Yep.
Yeah. So a lot of his stuff has been featured on there, a lot of his answers. And so if you want to soak up some of his knowledge, soak up some of Addie's, you're getting secondhand, crappy, filtered,
Hey.
not quite getting it, sort of, but almost got it, Addie style stuff. But,
Yes.
Yeah. Or if you want to hang out with Red and us,
Alex.
yeah, well, in the room he's Red.
Yeah.
So, if you want to hang out with us, we're on the Toymakers IRC channel on Afternet every single day.
Correctamundo.
All right,
Mhm.
guys, that's it for us for this week. Thank you, Red, or Alex, as it were,
Yep,
for
no
joining
problem.
us. We very much appreciate it. Thank you, listeners out there. We really, really, really like it that you guys are listening to the show, enjoying the show, whatever. Let us know if you know somebody who you'd like to hear on ZombieTech, and we'll try to make it happen. That's it for us for this week. You guys can find this show every Thursday. Well, when we have guests. During the holidays and wintertime, it's a little bit hard to get guests. But when we have guests every Thursday at ZombieTech.tv, there's an RSS feed there if you want to have it automatically downloaded to your phone, iTunes, whatever. Yeah, that's it for us. We'll see you guys next week.
Bye.